So in this video here, we're going to kind of wrap up the series of videos on solving trig equations, and we're going to wrap up with trig equations that involve the use of a calculator. So typically this occurs whenever you have to take a trig function and it equals something that isn't a value that you would typically find on the unit circle. So here we have the tangent of x is equal to 3. Well, that means that x is going to be some number of radians that we're going to rotate where the tangent is going to equal 3, where the opposite side over the adjacent side, that ratio equals 3. But that's not a value that we typically see on the unit circle. Normally we see values for tangent like root 3 or root 3 over 3 or sometimes 1, but we don't normally see it just equal to 3. So in order to be able to solve this, what we're going to have to do is take the inverse tangent of each side. So if we say that x is equal to the inverse tangent of 3, and we put that into a calculator that has an inverse trig function, the calculator is going to return a value that's going to be between negative pi over 2 and pi over 2, because the inverse tangent is restricted to the first and fourth quadrants there. So when I plug this in, the calculator tells me that x is approximately 1.249. So, well, what does that mean? Well, that means that I have some angle here that we'll put in standard position, so it starts on the positive x-axis, and it's going to rotate 1.249 radians. Okay, so wherever that value is, I'm just going to estimate. I know this is about 1.57 at pi over 2, so I'm going to say it's about right there. Okay, so when our point is here, that means that our trig function is going to have our tangent function rather is going to have a value of 3. All right, so one possible value for x then would be 1.249 radians. All right, and let's say we wanted to go ahead and we're going to restrict our domain, so that's between 0 and 2 pi, but we won't include the 2 pi. We'll just go say that x is going to be greater than or equal to 0 but less than 2 pi. And so one possible value would be this 1.249. Now the tangent is going to have that same value, that same positive value, all the way down here in the third quadrant as well. So I need to say that, okay, the tangent, whatever it is here, it's going to have the same value if I rotate 180 degrees or pi radians. That means that x is also approximate to 1.249 plus a half a rotation, which would be pi radians. And that's going to come out to be approximately 4.391. So if I was looking for all the solutions between 0 and 2 pi for which the tangent of x equals 3, I would say that x is approximately 1.249 and 4.391. If I was ignoring the 0 to 2 pi and I just wanted every possible solution, then I wouldn't need to do this part here. I would just have to say, well, I can use as many additional rotations as I want, additional periods, and just say plus pi n. Okay, but again, because we're restricting it here, we're not actually going to use that in this problem. Another example we can do is over here. If we have the cosine of x is equals this ugly number here, negative 0.4317, well, again, I'm not going to find that value anywhere on the unit circle without the use of a calculator, so we're going to have to say that x is equal to the inverse cosine of negative 0.4317. And when we plug that into our calculator, the calculator is going to return a value in the first or second quadrant, right? So it's going to be between 0 and pi, and the calculator tells me that's going to be approximately 2.017. Okay, so what that means is that our angle here, right, started at 0 and rotated 2.017 radians. All right, now remember we said that pi over 2 is approximately 1.57 radians, so 2.07 is about 2 radians. We're going to say that's just approximately right there. Okay, so that means that this angle here is about 2.017 radians, or that whatever this arc is right here is 2.017 times the radius. So we have to figure out, well, where else is the cosine going to have that same value? And well, since the cosine is really just equal to the x value, that means that we need to find another point on the unit circle that has the exact same x value. So we're going to draw a dotted vertical line right down here because that point would have the exact same x value. So I need to find, well, what is the radian measure of this angle here? Okay, so in order to do that, I know that I could go a positive 2.017 radians, or I could go a negative 2.017 radians. But since we want to keep our answers between 0 and 2 pi, so we're going to go from 0 to 2 pi, not inclusive, I need to be able to take this point in a positive fashion. So I'm going to take this point, which would be a negative 2.017. If I rotate this this clockwise direction, rather, I'm just going to go one rotation in the opposite. So I'm going to say x could also be approximate to a negative 2.017 plus a full rotation. Since a full rotation is 2 pi, when we plug that in our calculator, we're going to get x is approximately 4.266. So that means that all the possible values of x between 0 and 2 pi, for which the cosine of x is equal to a negative 0.4317, are going to be x is equal to, or I should say x is approximately, we'll say approximately here, x is approximately 2.017 or 4.266. Okay, and just like with tangent, if we were ignoring the restriction, if we did not have that 0 to 2 pi restriction, we would say x is approximately 2.017 plus 2 pi n, or x is approximately 4.266 plus 2 pi n. Okay, but again, because we had that restriction, we're going to keep these values here and these values here for the tangent. So I hope this video helps explain a little bit how you can use the calculator, even though there's a restricted quadrants when you use inverse trig functions, but we can still use the values we find in those calculators to help us solve these equations. Hope this helps, and I'll see you next time.